Neural networks in artificial intelligence. AI intermediate level. Introduction. Modern artificial intelligence systems such as image recognition, speech assistance, recommendation systems, autonomous vehicles, language translation, are powered by neural networks. Neural networks are the foundation of modern AI and deep learning. They are inspired by the structure of the human brain, where billions of neurons process and transmit information. In artificial intelligence, neural networks simulate this concept using mathematical models and algorithms. Neural networks allow computers to recognize images, understand speech, detect patterns in data, make predictions, generate human-like text. Today, neural networks power many well-known technologies such as voice assistants, facial recognition, self-driving cars, recommendation engines, modern AI chatbots. Understanding neural networks is essential for anyone learning machine learning and deep learning. What is a neural network? A neural network is a machine learning model inspired by the structure of the human brain. It consists of interconnected nodes called neurons that process data. In simple terms, neural network equals layers of artificial neurons that learn patterns from data. Example concept. Input data means neural network means prediction. Neural networks learn patterns by adjusting weights and biases during training. Why neural networks are important. Traditional machine learning algorithms require manual feature engineering. Neural networks can automatically learn complex patterns from raw data. Example concept. Raw data means neural network learns patterns means predictions. Neural networks are important because they can handle images, audio, text, video, complex datasets. This ability makes them the backbone of modern AI systems. Basic structure of a neural network. A neural network is made of layers of neurons. The main layers are input layer, hidden layers, output layer. Example structure. Input layer means hidden layers means output layer. Each layer processes information and passes it to the next layer. Input layer. The input layer receives the raw data. Example inputs. Pixels of an image, words in a sentence, sensor readings, financial data. Example concept. Image pixels means input layer. The input layer sends this information to the next layer. Hidden layers. Hidden layers perform the actual learning and pattern detection. Each neuron in a hidden layer performs a calculation. Example concept. Input means hidden layers learn patterns means output. The more hidden layers a network has, the deeper it becomes. This leads to deep learning models. Output layer. The output layer produces the final prediction. Examples. Image classification means dog or cat. Spam detection means spam or not spam. Price prediction means numerical value. Example concept. Neural network means final prediction. How a neural network works. A neural network processes data through a sequence of steps. Typical workflow. Input data. Down pointing arrow. Multiply by weights. Down pointing arrow. Add bias. Down pointing arrow. Apply activation function. Down pointing arrow. Pass result to next layer. Down pointing arrow. Generate prediction. The model improves by adjusting weights and biases during training. Activation functions. Activation functions determine whether a neuron should activate. Common activation functions include ReLU, sigmoid, tanh, softmax. Example concept. Neuron calculation means activation function means output signal. Activation functions allow neural networks to learn nonlinear patterns. Training neural networks. Neural networks learn through a process called training. Training involves feeding training data, making predictions, calculating error, updating weights. Example concept. Prediction means error, calculation means weight update. The most common training method is backpropagation. Backpropagation. Backpropagation is the algorithm used to update weights in a neural network. Workflow. Prediction. Down pointing arrow. Calculate error. Down pointing arrow. Send error backward through network. Down pointing arrow. Update weights. This process gradually improves model accuracy. Loss function. A loss function measures how wrong the model's prediction is. Example concept. Actual value versus predicted value means loss. Common loss functions include mean squared error, cross entropy. Lower loss means the model is performing better. Types of neural networks. There are many types of neural networks designed for different tasks. Feed-forward neural network. The simplest neural network structure. Data flows in one direction. Input means hidden layers means output. Convolutional neural networks. CNN. Used mainly for image recognition. Applications include facial recognition, object detection, medical imaging. Recurrent neural networks. RNN. Designed for sequence data. Applications include language modeling, speech recognition, time series prediction. Transformer networks. Modern neural networks used in large language models. Applications include chatbots, translation, text generation. Transformers power many modern AI systems. Real-world applications. Neural networks are used across many industries. Computer vision, image classification and object detection. Natural language processing, language translation and chatbots. Healthcare, medical image analysis and disease prediction. Finance, fraud detection and stock prediction. Autonomous vehicles, self-driving car perception systems. Advantages of neural networks. Neural networks provide several benefits. Advantages include ability to learn complex patterns, automatic feature extraction, high accuracy for large datasets, adaptable to many AI problems. Example concept. Large data plus neural networks means powerful AI models. Limitations of neural networks. Despite their power, neural networks have limitations. Limitations include require large datasets, require high computing power, training can be slow, sometimes difficult to interpret. Example concept. Complex model means harder to explain decisions. Example Python code. Simple neural network. Neural networks can be implemented using TensorFlow or PyTorch. Example with TensorFlow. Import TensorFlow as TF. From TensorFlow, Keras import layers. Model equals TF, Keras, sequential. Layers, dense. 64. Activation equals ReLU. Layers, dense. 10. Activation equals softmax. Model, compile. Optimizer equals atom. Loss equals sparse underscore categorical underscore cross-entropy. Metrics equals accuracy. This simple neural network can be trained on datasets for classification tasks. Concepts learned from neural networks. Understanding neural networks helps learners understand. Checkmark how modern AI systems learn patterns. Checkmark how deep learning models work. Checkmark how image and speech recognition systems operate. Checkmark how large AI models are trained. Checkmark how modern artificial intelligence applications are built. Neural networks are the core technology behind modern AI breakthroughs. Simple definition. Neural network. A machine learning model made of interconnected artificial neurons that learns patterns from data to make predictions. Final summary. Neural networks are one of the most important technologies in modern artificial intelligence. Inspired by the human brain, they consist of layers of artificial neurons that process and learn from data. Through training and backpropagation, Neural networks can detect complex patterns in images, text, audio, and other data. Because of their power and flexibility, neural networks drive many modern AI applications such as computer vision, speech recognition, and large language models. Understanding neural networks is essential for anyone studying machine learning, deep learning, and artificial intelligence.